Okay, so we've got this foul-smelling gas. We want to figure out its molecular formula and name. In this case...
Take a film of it, and we're going to beat you.
Shut up, I have to pose for a picture. No, we're disturbing.
Would you like it scrambled or easy over?
Okay, that doesn't make any sense. All right, so to solve this problem, we see that there's nothing changing. So there's no volume change, no pressure change. There is a reaction, but that doesn't count as a change in this category that we're talking about, this concept. So, because of that, what we're going to do is we're not going to use a combined gas law, we're going to use the ideal gas law this time. But before we use it, let me tell you a little information. So we're going to do, let me give you a couple notes before we actually try to solve this problem. Because there's some funny things in here that we wouldn't expect, like mass, for example, or we want the molar mass. So when you have these funny variables, we have to, in particular, do something. And well, often, if we're asked for, say, the molar mass, or the density, or the mass, or something like that, it's one of these specialty ideal gas law problems, but it's still an ideal gas law problem. What you need to know is a couple things. The molar mass is the mass over the moles. Molar mass is the mass over the moles. And then the density from before is mass over volume. Because we have this moles right here, we can always substitute into the ideal gas law. So we're going to make some substitutions of kind of unusual variables into the ideal gas law. So let's try that. And really, you can write it out like this. You could say, well, N is mass over molar mass, for example, RT. And you kind of substitute things in like that, depending on what you need or what you want in the question. For example, mass, you could substitute in this mass, and that would be density times volume over molar mass, RT. Something like that. So those kind of substitutions is what we'll need to do. So let's try it for this problem. I'll do a different color. Okay. So we need, let's see, the molecular mass of the gas and its formula and name. Well, there's a couple things you can do. First, I'm given, there's really two ways to solve this problem, and I'll show you both ways. You can use that conversion, since you know it's an ideal gas, 22 liters per mole. You learned this earlier during Charles' law. And you can find basically 1 over 22.4 moles. Then you can say, well, the molar mass is just mass over moles, which would be the mass is 1.52 given in this problem, and the moles is 1 over 22.4. This turns out to be 34. So you notice we did the whole problem just using this conversion. But you could have also, I'll get a different color, had an alternate solving method using, as I mentioned, the ideal gas law. So if we want the ideal gas law, I could substitute in for N. The N is the mass over the molar mass times RT. And I really want to solve for the molar mass. So the molar mass is MRT over PV. So it's like an alternate way to do the ideal gas law, making a little substitution. Substitute that all in, 1.52 grams. Same R as before, 0.08206 liters atmospheres per mole Kelvin. Same temperature, and that was 273. pressure, let's see, what was the pressure? 1 atmosphere. 1 atmosphere. And the volume was 1.0 liters. If you do this, you'll get the same answer of 34 grams per mole. So 2 things you can know about this. This is how you use the ideal gas law to solve for something that's not like mass, volume, moles, that sort of thing. The second thing you can know, that conversion of 22.4 liters per mole, that actually is derived out of the ideal gas law. So whenever you use that, you're actually using the ideal gas law. So that's a variant, or maybe a kind of a quicker way, if you want, of using the ideal gas law is when you use that conversion. If you use that conversion, you have to be at or close to STP. Okay, if you're not at or close to STP, that conversion won't work
I
very
have
well.
a question for you, Dr. Emily.